You know that to protect your data, you have to store more than just one copy of that data on your system. That redundancy can be as simple as mirroring the data on your local system, or as complex as a multi-site intercontinental high availability configuration. Traditional enterprise storage systems all support redundant arrays of independent disks, known as RAID, to protect against disk failures. But many of the traditional RAID levels are designed to handle only one or two disk failures in the group. With today's larger capacity disk drives, when one disk fails, it can take days to rebuild data and restore redundancy. The ability to tolerate only one or two failures is just not enough redundancy to protect your data. Erasure coding is all about making data highly available. In simple terms, it breaks data into a configurable number of chunks, computes an arbitrary number of additional checksum chunks, and distributes those chunks across a set of different storage systems. By choosing the ratio of data to checksum chunks, you can choose the additional capacity you need for the level of data protection you desire. In the event of failure, the system can reconstruct the missing copies, keep your data available, and return the system to a fully redundant mode. Think of it as the next generation of RAID, because it gives you redundancy far beyond RAID's one or two failure model. The resiliency of the data you store through erasure coding depends entirely on the values you specify. SUSE Enterprise Storage allows you to change two values to meet any resiliency standard you wish to define. Let's take a look at an example. For instance, K10M6 is a common choice. Choosing these parameters ensures that the data is divided into 10 blocks and that 6 erasure code blocks are computed, spread over a total of 16 drives. Any 10 of those drives can recover data, which means any 6 drives can fail, and you only need 60% additional storage capacity to get this high level of protection. The result? Erasure coding gives you far greater control over your data's resiliency and availability than a traditional RAID array can provide, and at a much lower cost.